Great, thank you, Alonso. And so what I'm going to do is just tell you a little bit about what you're going to see today and how we got there. So Ramon mentioned that coming from our mines in Brazil and Chile, we're going to have a mixed material. Very, very pure, but it's a mixture. And there are many different rare earths. Every single one has a different application, a different price point. And so it's of no use for us to have a mixture. We need to separate them. So what we had to do is then choose the technology. And how this has traditionally been done in industry is called a technique called solvent extraction, or SX. You'll see that through the presentation. Now, there are many other ways to do it, but this project is of strategic importance. Time is everything. And so we chose a technology that is tried and true. We know it works, and this will really accelerate our timeline. But the big problem that we had is that in the Western Hemisphere, in the Americas, no one's been separating heavy rare earths. This technology really doesn't exist. So we had to do a big sweep of who we can work with, our collaborators, that can help us work at Aclara speed. This is a term we've coined, speed with quality, right? And it's really challenging because we understand the strategic importance, and we're here to serve our customers. So we identified several collaborators that Ramon's mentioned, but I'll kind of give you my take on it. So to Virginia Tech and Dr. Noble, there are people who've been working in this field for a while. We have just amazing access to talent, problem solvers, and also capabilities. The Virginia Tech just has this infrastructure that we can leverage and help us, and that's the reason why we're here. So tremendous support. But the other thing is this process, and you'll see it when you walk through, it's really complicated. And to work, if we were going to start from scratch and do this, you're talking years of development. So we're working with a company, L3 Process Development, Tommy, who Ramon mentioned, and L3 has over 10 years of experience on this, and they have proprietary modeling techniques. So they were able to take the composition of our clays and be able to help us develop this process. So what you're going to see, we're not actually doing, pure R&D. This is demonstration. It's validation. We just need to do the fine tuning so that we can produce the samples to give to our clients to prove we can do it. And then also fine tuning before we order the equipment for the industrial plant. So there's going to be a test later. William on the tour will give you another run through, so you get two chances, but then we'll do a test before you leave. So we take, coming into SX1, we take this mixed rare earth carbonate, just think of it like a white powder, and we dissolve it. And in SX1, we're taking 3 cuts. And so we have a light cut for light rare earths, then we have the heavies and the super heavies. The lights going into SX2, we make into NdPr, so light rare earth oxide. And we do that, we get a solution out, and essentially we precipitate and calcine. And so where we separate the dysprosium and terbium. Very difficult to do. We're pulling out, we call it seg coming out in the middle. I won't get into the fancy names, but that's going to be a byproduct. And then we separate dysprosium in SX4, and in SX5 we separate the terbium. Those products then get precipitated and calcined, essentially heated up to turn them into an oxide. These are the products that go downstream to what our customers need. So that's the process. And a key challenge that we have in this process, you can see how complicated it is from a picture, but Ramon mentioned some mining terms. If you've ever worked around process controls, and you have a process that has a lot of time to get through the process. We've got over 300 cells that Eduardo was mentioning. And then I bring things back to the front. This makes a control, and the engineers have nightmares over this. So this is where Argonne National Lab steps in with the digital twin. Essentially, if we simplify it down, we need a system that's helping us watch the process, tell us when we're going to have a problem, and how to solve it. And the way to model this process, that's known, but how to actually solve this model, in the past, that hasn't been possible. But now with today's computing power, and then you layer on top of that machine learning and the artificial intelligence component, we can have a system that's watching and telling us what to do. and tell us how to do it without upsetting the process. So it's an absolutely key way, and that's how we're going to catch up in terms of getting the Americas up to speed in heavy rare earth separation. Absolutely key tool. So then all of this, Ramon mentioned in Louisiana, we have engineering going on right now. And so we are engineering a very large facility. Think of a distribution warehouse. When you go in the pilot plant, you'll see this is quite small equipment. So we can develop this shell, bring in the small equipment, and then we'll be up and running in 2028. So super exciting. I'm so grateful for everyone who came, especially those who traveled, and we look forward to showing you what we've done. And I just want to congratulate the team. 5 months ago, the shell that you see, it was nothing. We hadn't got the floors done, we hadn't ordered equipment. In 5 months, we've got it all the way to where we are today. So just to William and Dwayne and the team, congratulations.